Let me ask you something that sounds simple. If we can go to the moon, if we can send robots to Mars, if we can land those robots gently on the surface, take pictures, drill rocks, send selfies across millions of miles, why can't we just go to Mars and come back? I mean, really, why not? People say it as if it's obvious. Of course we'll go. Of course we'll colonize it. Of course we'll come back. But physics is not impressed by confidence. Physics does not negotiate. And if you listen carefully to what nature is telling us, not what we wish it were telling us, you begin to see something uncomfortable. Returning from Mars is not just difficult. It may be, in a very deep sense, nearly impossible. Now, when I say impossible, I don't mean like flying pigs. I mean something subtler, something more insidious. I mean that every single step required to leave Earth, land on Mars, survive, and return stacks difficulty upon difficulty until the problem becomes monstrous. Let's start with something basic. To leave Earth, you have to fight gravity. Gravity is like a deep well. Imagine you're at the bottom of a giant canyon. To get out, you must climb all the way up the wall. You don't just step sideways and drift off into space. You must climb. And climbing takes energy. A lot of it. Now here's the strange thing. Most of the rockets sitting on the launch pad isn't astronauts. It isn't scientific instruments. It isn't even the spacecraft. It's fuel. Tanks and tanks and tanks of fuel. Why? Because to carry fuel, you need fuel. And to carry that fuel, you need even more fuel. It's like trying to carry enough gasoline to drive around the world, while also carrying all the gasoline you'll need to carry that gasoline. It explodes in size. Now imagine you successfully climb out of Earth's gravity well. Congratulations, you're in space. But space isn't empty in the way people think. It's empty of air, yes. But it's not empty of gravity. The sun is pulling on you, Earth is pulling on you, Mars is pulling on you. Space is more like a rolling landscape of invisible hills and valleys. You have to aim very carefully to roll from one valley into another. To get to Mars, you don't just point your rocket and fire. You have to wait for Mars to be in the right position. It's like throwing a dart at a moving target from a moving platform. You fire yourself out into space at exactly the right speed, at exactly the right angle, months in advance. Miss by a tiny amount? You miss the planet. Now suppose you get there. Mars looks friendly in pictures. Rust-colored deserts, big sky, nice sunsets. But Mars is not friendly. Mars has gravity, about a third of Earth's. That sounds helpful, right? Easier to walk, easier to lift things. But here's the problem. It's enough gravity to trap you, but not enough atmosphere to protect you. Mars has a thin atmosphere, very thin, too thin to breathe, too thin to slow you down gently when you land. Landing on Mars is a nightmare. If there were no atmosphere, you'd just slam into the surface unless you carried enormous amounts of rocket fuel to slow down. If there were a thick atmosphere like Earth's, parachutes would work nicely. But Mars gives you the worst of both worlds. Enough atmosphere to heat you up violently as you enter, but not enough to slow you down. So you need heat shields, you need parachutes, you need retro rockets, you need perfect timing. One small mistake, and you dig a new crater. Now let's assume you land safely. Wonderful. You are now standing on another planet. But here's a question people don't like to think about. How do you leave? Because when you left Earth, you had a giant launch pad. You had thousands of engineers. You had supply chains. You had factories. You had rescue systems. On Mars, you have what you brought. That's it. And what you brought has to include a rocket powerful enough to launch you off Mars, push you into orbit, and send you back toward Earth. Think about that. You must land with the return rocket already there, or you must manufacture fuel on Mars. Manufacture fuel. On a frozen desert planet, millions of miles from spare parts. Densest desert faced. The nearest, densest, and the number of the open miles faced, densest. This temperature is there, so every visible closer is there restored. Then, a few minutes later, responses. Then no. Then no. Do you see the scale of the problem? It's not just go there and come back. It's bring everything you need to survive for years. Bring equipment to produce oxygen, produce water, shield yourself from radiation, grow food or bring food, maintain machinery and dust storms that cover the entire planet. Mars dust is nasty stuff, fine as powder. It gets into everything, it clings through static electricity, it damages seals and joints. And while you're dealing with that, cosmic radiation is pouring through your habitat. On Earth, we're protected by a thick atmosphere and a magnetic field. Mars has neither. You are essentially living inside a thin metal can, being slowly exposed to radiation that increases cancer risk, damages cells, and accumulates over time. So staying long enough to wait for the right alignment to come home, because you can't leave anytime you want, is itself a risk. Ah yes, the timing. Here's another little detail people skip. Mars and Earth orbit the Sun at different speeds. To travel efficiently between them, you must wait for a specific window that opens roughly every 2 years. Miss it, you wait. You don't just call Uber Earth and say, "Come get me." You wait. Possibly more than a year. On a planet where everything that keeps you alive is fragile. Now think about what it means to launch from Mars. You need fuel. Lots of it. If you bring that fuel from Earth, your launch weight from Earth becomes enormous. Remember that fuel explosion problem? Fuel to carry fuel to carry fuel. It balloons. So engineers say, we'll make fuel on Mars, we'll use carbon dioxide from the atmosphere, we'll split water for hydrogen. Good idea. But now your survival depends on chemical plants working perfectly in a hostile environment, unattended for months before you even arrive. Because you'd better have the return fuel ready before you risk landing. If that fuel plant fails, you live on Mars. Forever. Now here's where physics becomes merciless. Energy requirements don't care about optimism. Every kilogram you want to bring back must be accelerated to escape Mars' gravity. Then accelerated toward Earth. Then slow down safely upon arrival. And mass multiplies the energy required. And humans are heavy, fragile cargo. We need air, water, food, pressure, temperature control. You cannot fold a human into a tiny capsule and store them like a robotic probe. Robots are forgiving. Humans are not. A robot can take radiation. A robot can freeze. A robot can shut down for months. A human needs continuous life support. Continuous. For years. Now let's think about psychology. Because physics is only part of the story. Imagine you're 6 months into your journey to Mars. Earth is a pale dot. Communication delay is 20 minutes each way. You say hello. 20 minutes after that, you hear their reply. There is no real-time conversation. You are alone. Then you land. You live in a small habitat with a handful of people. For years, every problem is your problem. Every repair is your responsibility. There is no emergency evacuation. If your appendix bursts, you'd better have a surgeon. If a system fails, you fix it or you suffocate. Now suppose everything goes right. Miraculously, the fuel is ready. The launch system works. You blast off from Mars. You reach orbit. You burn your engines toward Earth. Months pass again. Then you approach Earth. But here's the final twist. Earth's gravity well is deeper than Mars's. You fall in fast. Very fast. You must survive re-entry, the heat, the deceleration. You must land safely. And every part of your spacecraft has aged years in deep space radiation. Do you see the pattern? At every stage, nature adds another demand. It's like climbing a mountain where each ridge reveals another higher ridge. Now here's something important. When I say returning from Mars is impossible, I don't mean humanity will never do it. I mean that it requires a chain of perfection so long, so delicate, that the probability of failure accumulates. Each step might be 99% reliable. Sounds good. But if you have 1,000 critical steps, each 99% reliable, the chance that all succeed drops dramatically. Space is unforgiving. On Earth, if your car breaks down, you pull over. In deep space, if your life support breaks down, you die. That's the difference. We evolved in a thick blanket of air, under a magnetic shield on a warm ocean world teeming with life. Mars is a frozen desert world. Going there is not like sailing across an ocean. It's like jumping off a cliff and building your airplane on the way down. Now you might say, but we're clever. We'll solve it. Yes, we are clever. Humans are astonishing. We split the atom. We map the genome. We built machines that think in limited ways. But cleverness doesn't repeal the laws of physics. Energy must come from somewhere. Mass must be lifted. Radiation must be shielded. Time must pass. And time out there is expensive. There's something else here, something philosophical. Mars tempts us because it feels like escape. Earth is messy. Climate change. Politics. Conflict. Mars looks clean. empty, a blank slate. But Mars is not a backup Earth. It's a reminder of how special Earth is. On Earth, you walk outside and breathe. You drink water from rivers. Plants grow under open sky. You don't need a machine between you and survival. On Mars, every breath is manufactured. Every drop of water is recycled. Every degree of warmth is engineered. We talk about colonizing Mars as if it's pioneering the American West. It's not. The American West had air. It had water. It had soil. Mars has dust and cold and radiation. It's less forgiving than Antarctica. In fact, it's less forgiving than the vacuum outside your spacecraft, because at least in open vacuum you expect hostility. Mars pretends to be a world. That's the trick. It looks like a place. But it's barely a planet for life. Now let me turn this around. Why do we want to go? Curiosity. That's beautiful. Curiosity is one of the finest human qualities. We want to know. We want to stand on another world and look back at Earth rising in the Martian sky. We want to feel that expansion of perspective. And maybe we will. But if we do, it will not be casual. It will not be routine. It will be one of the hardest things humanity has ever attempted. Harder than building pyramids. Harder than crossing oceans, because oceans still belong to Earth. Mars does not. And here's the deeper warning. When people speak lightly about colonizing Mars, they reveal a misunderstanding of our home. If it takes staggering energy and technology just to survive on Mars for a few years, what does that say about how miraculous Earth Alfred Addy is? Earth is a spaceship that works without maintenance from us. The atmosphere circulates. Water cycles, ecosystems balance, sometimes delicately, yes, but naturally. On Mars, you must build a tiny artificial Earth inside metal walls. And even then, you are vulnerable. So perhaps the impossibility of returning from Mars is not just technical. It's educational. It teaches us that planets are not interchangeable. It teaches us that life-supporting worlds are rare and precious. It teaches us humility, because nature is not impressed by our dreams. It will allow us to explore, yes, but it will charge full price. Every kilogram, every joule, every mistake. And maybe that's good. Maybe the point of Mars is not to escape Earth. Maybe the point is to understand Earth, to look at that barren desert world and realize what we have, to feel deeply that thin blue line of atmosphere hugging our planet is a miracle. Returning from Mars may be nearly impossible, not because rockets are weak, but because reality is strict. The universe is vast and beautiful and indifferent. It does not bend. We must bend, we must calculate, test, fail, try again. And maybe one day a small group of brave humans will go to Mars, live there, launch back, and splash down on Earth. If they do, it will not be because it was easy. It will be because thousands of invisible problems were solved, one by one. It will be because we respected the difficulty, because we listened to the warnings hidden in the physics. And even then, the margin will be thin. So when someone says, "We'll just go to Mars and come back," smile. Then ask them gently, have you thought about the fuel? Have you thought about the radiation? Have you thought about the waiting? Have you thought about the fact that every breath must be made by a machine? Mars is not impossible, but it is not forgiving. And returning from Mars is a chain of miracles tied together by engineering. It is a bet against entropy, a wager against isolation, a dance with gravity wells and cosmic rays. And maybe that's why it fascinates us, because it forces us to confront the scale of the universe. It forces us to confront our fragility. It forces us to grow up as a species. You see, the real warning isn't "don't go." The warning is, understand what you're asking. Understand that space is not a backdrop for adventure stories. It is a harsh, quiet ocean without air. And Mars is a distant rock orbiting a star that does not care whether we arrive or return. If we choose to go, we must go with humility. We must go knowing that coming home will be one of the hardest parts. And perhaps in contemplating how difficult it is to leave another planet, we learn to cherish this one. Because right now you can step outside. You can breathe. You can feel gravity holding you gently to the ground. You can look up at the night sky and see Mars shining faintly. It looks small, harmless, inviting. But between you and that red dot lies a lesson in physics, in patience, in respect for nature. Returning from Mars is not just a technical problem. It is a mirror that shows us how finely tuned our existence is, how thin the margin is between survival and vacuum. How extraordinary it is that we are here at all. And maybe, just maybe, that realization is more important than planting a flag. Because the greatest frontier might not be Mars. It might be understanding the planet beneath your feet. And that, my friends, is a journey we can begin today.